The structure and storage polysaccharides. Learning objectives. Recap how polysaccharides are formed. Describe the roles of cellulose, starch and glycogen in plants and animals. Explain how the structure of these polysaccharides relates to their function in plants and animals. Starter questions. Which polysaccharide makes up plant cell walls? Which monosaccharide makes up this polysaccharide? Is this polysaccharide branched or unbranched? Cellulose, main structural sugar in plants. Structural component of plant cell walls. Very strong. Also permeable to numerous substances. About 33% of plant matter. Most common organic compound on Earth. Why can't humans digest cellulose? We don't produce cellulase. Ruminants, like cows, have symbiotic bacteria in their stomachs. Starch amylose, alpha helix -20% of starch. Amylopectin, branched starch -80%. Amylopectin. Amylopectin highly branched. Can be hydrolyzed more quickly than amylose. Alpha-glucose molecules joined by alpha-1 to 4 glycosidic bonds with alpha-1 to 6 branches every 20 to 30 monomers. Plants store it then hydrolyze it. When they need a supply of energy. Glycogen, same subunits as amylopectin but much more branched. The storage sugar found in animals. Made mostly by the liver and muscles. Stored as granules in the cytoplasm of cells. Can be quickly hydrolyzed when energy supply needed. Questions. Compare and contrast the structures of glycogen and cellulose, showing how each molecule's structure is linked to its function. 10 marks. 2. Compare and contrast the structures of starch and cellulose, describing how each molecule's structure is linked to its function. 12 marks. Mark scheme. 1. Glycogen is a chain of alpha-glucose molecules. 2. Cellulose, chain of beta-glucose molecules. 3. Glycogen's chain is compact but very branched, whereas, 4. Cellulose's chain is very long, straight and unbranched. 5. And these chains in cellulose are bonded to form fibers. 6. Glycogen's structure is very compact, which makes it a good food store in animals. 7. The branches allow enzymes to access the glycosidic bonds. 8. To break the stored glucose down quickly, which is important for energy release in animals. 9. Cellulose chains are linked together by hydrogen bonds to form fibers called microfibrils. 10. These strong fibers provide structural support for cells, for example plant cell walls.